Hi, everyone. Good afternoon. Welcome to this session. Today, Paul Ganssle will be talking about pytest for unit testers, and then we'll have a Q&A session. Okay.
Sure.
Welcome.
Hi, thanks for coming. My name is Paul Ganssle. I'm a software engineer at Google and a maintainer of a few open source packages. Notably, I'm a CPython core dev, so I've mostly been working on datetime and zone info lately for the past few years. Today, I'm going to be talking about pytest, and specifically this talk is aimed at audiences who have historically used unittest or one of its derivatives. So like at Google, we tend to use our own derivative of unittest called absoltest, but as a big fan of pytest, I wanted to put together a kind of coherent case for why I think pytest is likely to be a better choice in today's world, and why and how you might want to migrate your unittest-based workflow to pytest. So this talk barely scratches the surface of all the features that pytest has, but I hope that it might highlight some of the advantages that pytest has for those of you who are considering a migration, or if you're deciding between unittest and pytest, or if you're just not familiar with pytest, but you're very familiar with unittest. Okay, so to sort of address the elephant in the room, a common objection to pytest is that it is way too magical, right? It selects tests based on their name, it rewrites the bytecode, it does all kinds of path manipulation and other magical stuff. And obviously the worry people have with that is that because of all the magic, it can be hard to reason about pytest behavior. It's gonna break all kinds of stuff, right? And I will tell you something, as a huge proponent of pytest is way too magical. It is absolutely true. But the other thing I'll say is that in practice, it does not seem to matter all that much. If you had shown me pytest when it was like a young upstart and no one was using it, I would have thought that you were introducing a bunch of implicit behavior. It was going to lead to like terrible technical debt and unmaintainable code. But pytest is not a young upstart framework anymore, right? It's in fact basically the standard way to do testing in Python these days, and for good reason. But I haven't really seen the problems that you would expect magical code to manifest come to pass. These things mostly just work, and so I think there's good reason to sort of temper your skepticism on that, in that regard. So now that we've gotten that out of the way, let's take a look at some of the specific ways that pytest is magical. The first major difference you're going to notice between pytest and unittest is that unittest uses these assert equal methods, or just these assertion methods that are methods on your test case object, and pytest uses bare asserts. The first reason that unittest uses these methods is that if you were using just bare asserts, right, your test runner is going to catch some assertion error, and that assertion error is just going to say, this thing was not true, and it'll get your custom method, right? Whereas with an assertion method, you're giving it both the things that are supposed to be true and the equality semantics. And so it's able to construct this nice error message that's saying like 1 is not equal to 2, and you were expecting 1 to equal to 2, and then give you your error message. If you didn't have that, you would have to construct some custom error message for every single one of these, and it would be very repetitive. But this is the first way that pytest is magical, because with pytest, even though you're using assert statements, it's still giving you this nice clean error message, including the operands and the operation that happened. And the way it does that is that before it executes any code, it actually compiles your tests into bytecode, and then it goes into that bytecode and it rewrites it to extract the relevant information and then change the way it raises errors so that you get this nice information here. Now, another reason that unittest avoids the assert statement is that when you run Python in -o mode, right, in optimize mode, it removes all the assert statements, right? So you may want to run your Python code in -o mode, and if you're going to do that, you should probably test it. But if you test it and it strips all the assertions out of your test code, that's not really a good test suite. pytest, again, because of the bytecode rewriting, is able to fix this, because what it does is it rewrites all the assertions only in the test methods in such a way that they won't get stripped out, but it leaves the ones in your package that's under test in place. So you can still run your tests in optimized configuration and it'll work just fine. The last problem with assert statements, and this is actually a problem with assert in general, not just in testing, is that it's subject to this particularly nasty and easy to overlook bug. So if you're looking at these two code blocks, you might expect them to be equivalent, right? The first one is breaking up the two arguments to assert with parentheses so they can go across multiple lines. And the second one uses a line continuation. So you'd think, oh, these are the same, right? But no, the first block is actually equivalent to this second block, because when you put parentheses around something that has a comma in it, that's the way to define a tuple. And so now what you're doing is you're asserting that this tuple is true, and it's a non-empty tuple, so no matter what that first argument to assert is, this is always going to be true, and it's a no-op. PyTest doesn't have a solution per se to this, or it doesn't solve it per se, but it can recognize that it's happening and raise a warning. And it's fairly easy to configure PyTest to just turn that warning into an error, and I recommend that you do that. Okay, so far we've seen some problems that can be caused by assert methods and the way PyTest solves them, but why is PyTest bothering to do this? Why does it care so much about using this bare assertion style? Well, one of the big advantages of using this style is that you don't need this huge proliferation of custom assert methods, right? In unittest, you have to have a separate method for asserting is not none, less than, greater than, less than and equal to. And if you want to make some more complicated assertions, right? Like, for example, you want to you want to assert that the length of something is not equal to some other thing, right? We have a custom extension for that in absoltest. These things all require additional methods on your test case. With PyTest, you can just use the normal semantics of the language, and it will sort of get out of your way and create the error message that you want to see. And in fact, it has this very nice feature where if the two operands if one of the operands is a function and the other one is a value, or if either of them is a function actually, what it will do is it will take those functions, it'll show you what the values were that didn't compare equal, and then it will also expand those values to be the functions that generated those values. So you don't need this sort of custom mechanism to say, oh, I was using this function and things like that. But hold on, you might say. What about floats? Don't we need some custom assertion for floats? Because floats are, you can't just compare them directly. You have to use this sort of fuzzy equality for floats. For floats specifically, PyTest has this thing, the approx wrapper, and it's fairly simple to do. What you do is you just import PyTest and you wrap your float in approx. And what approx is it's a wrapper object that has fuzzy equality semantics. So it just it compares equal if there's some sort of fuzzy equality between the thing on one side of the operation and the thing on the other side of the operation where one of them is a float. And this is actually a more general strategy that you can use. So this one's built in, but you can also just create your own objects that have whatever equality semantics you want, and you just wrap them around your inputs to get to get this sort of custom equality semantics that you would normally get from a custom assertion method. Okay, another nice advantage of PyTest is the way it displays errors when there's a failure. So for example, take this test. It generates a bunch of date times, and it checks to see if they satisfy this round-tripping property. And you'll notice that with unittest, the result you get is not exactly useful, right? You see that the operands are not equal, but they're just these large numbers, right? I don't know what date times generated them. If we were to write a similar test in PyTest, you can see that what it's going to do is it's going to do that thing where it expands out the functions, and it's going to say, oh, one of these things was a date time, and this is the date time that it was. It's now immediately obvious to me that where I should start this debugging process, right? And you may also think, okay, Paul, you're sort of putting your thumb on the scales with all this bolding and the color and whatnot. But actually, that is how PyTest outputs look. Unittest is sort of plain text. PyTest makes use of color and font to highlight the relevant information that you should be looking at in your test. And in fact, if you have pygments installed, it will also do code highlighting on the little fragments of code right in your console. And if you think that maybe you can't use pytest quite yet, another advantage of pytest is that it's actually backwards compatible with unittest. So you can get some of the advantages in the error messages from pytest even without migrating away from unittest, because pytest and unittest, they're both test runners as well as test frameworks, right? Unittest's part of the test framework is the structure of the classes and stuff, and pytest has things like approx and other features you're going to see. But you don't have to switch your test framework just to use pytest. If you just take pytest and run it on unit test classes, it will work. Now, it won't give you some of the nice advantages like the rewriting, right? We're not seeing that len of a is not equal to 4. We're seeing 3 is not equal to 4. But in fact, you can get something like that even in unit test cases with pytest. See, let's go back to the datetime example. If you look at the datetime example, running it normally with pytest still gives you the same problem as with running it with unittest. But if you run pytest with -l or --show locals, what it's going to do is it's going to capture all the local variables in the scope of the test when it failed, and it will enumerate them right in your test message. And that gives you a lot more information. And again, this gives you enough information to start debugging. And it's going to be a lot more verbose, but because it gives you that extra information, you may also want to run even your just regular pytest tests this way. Speaking of running pytest as a test runner, it also has very useful interactive debugging features. One that I really like is -x. It's basically just run your test suite until the first failure and then stop. There's also an iterative version of that called stepwise, where if you run pytest -stepwise, what it's going to do is it'll run to the first failing test, it'll stop, and then the next time you run it in stepwise mode, it will start at the last failing test and run until the next failing test, right? If that one fails, it'll just run it again, right? So that's a good way to cut down the latency on your debugging cycles. It has a lot of options for like how you would order the test. You can run the failing ones first, or only run the ones that failed last time. And it also has this very useful feature, --PDB. And what that does is, if your test fails, it immediately drops you into a debugger. And so now you're just working in the debugger, and you can play with the failing test, and you're in that scope. But you might be thinking, well, we can't migrate away from unittest as our test runner because we have some sort of orchestration around the outputs of unittest. Well, chances are, if you're doing that, you're probably using some sort of XML format anyway, and there's a good chance that either pytest supports that out of the box because it's this standard JUnit XML format, or a plugin exists for that. So you may find that a migration to pytest is easier than you would think. Okay, so if you do want to migrate away from unittest as not just a test runner, but as a testing framework, the main thing you're going to the first thing you're going to notice is that classes are now optional, right? In unittest, you needed everything to be in a test case. That's how test discovery was handled, and that's how assertions were handled. In pytest, test discovery is handled based on naming conventions. These are configurable naming conventions, so you don't have to change your naming conventions. But because of that, people generally don't use classes to organize their tests. They just use these, they put them in modules, and they're just bare functions on the module. Setup and teardown is generally handled with fixtures. But if you want, you can do a sort of incremental migration by just making your test cases not inherit from unittest.testcase, and it will still work. PyTest supports putting your tests in classes. It also supports setup and teardown methods, both at the class level, at the function level, or at the method level, and even at the module and function level. But I think a lot of times people don't use this sort of strategy in PyTest because of a phenomenon that I've seen many times in like Python help chats, where someone comes and they're like, I have this complicated abstract set of meta classes or whatever, and then you're like, why do you have such a complicated hierarchy? And they're like, well, it's to get all the right assertions in the right place or whatever, right? Because they're trying to use like mix-ins and some sort of complicated inheritance hierarchy to get the right methods on their unit test cases, or to share test cases, or to share data or something, right? But what if I told you that you could actually have modular composable test code without mix-ins, without inheritance at all, actually? And that's where fixtures come in. So this is the basic anatomy of a fixture. It's just a function. You have some setup code, and then you have a yield, which yields the payload of the fixture. This is what's going to be passed to the test function. And then after the test function executes, whether it passes or fails, all the code after the yield gets executed. So it goes setup, yield, teardown. The way they're actually used is you register one of these things as a fixture. Now, here's the tricky part. It's going to use the name of the function as the way to pass it to your tests, right? So in this case, what it's doing is registering config_dict as that fixture, and then any function that takes a parameter named config_dict, that's going to get the fixture executed, and then it will pass whatever that thing yields, and then it'll execute the teardown. So in this case, we have two functions that use it and one function that doesn't. The middle one mutates it. That's okay, even though it's a mutable dictionary, because there's a new function call every time. Fixtures are also modular. So fixtures can call other fixtures. So, sorry, that's not it's not that fixtures can call other fixtures. It's that you can use any combination of fixtures in your test functions, right? So in this case, we have one function that wants random user and one function that wants both random user and config_dict. We don't have to worry about making sure that the setup and teardown for both of these fixtures is happening on the same class, or figuring out what combination of classes will accommodate that. We just write our tests as we want, and then we request the resources that we want, and that's what we get. Fixtures are also composable. This is the one where fixtures can call other fixtures. So in this case, I have random user, it generates a user. If I want a random user with a home directory in a temporary path, we have random user with home, which uses both the random user fixture and the built-in temporary path fixture. It constructs the temporary path, assigns it to the user, and then yields that. And then anything that wants to use that can just use my composed fixture. Now you might think, okay, well, a natural thing to do would be, I'd like to be able to pass a parameter to these fixtures because they should be reusable test code, right? I will say that the UI for this is not great. There are two different ways to do it, and I don't like either of them. The first one is indirect parameterization, and the way that works is you just have this request parameter in your fixture, and then anytime you want to use that, you use this pytest.mark.parameterize marker. And what this does is you just tell it which fixture you're passing parameters to. You tell it the parameters to pass, and then you say indirect is true, and that's indirect parameterization. So in this case, it's going to pass Jose to this random user indirect fixture. The other way to do it is direct parameterization. So it turns out that this pytest.mark.parameterize, it will just overwrite any fixture that exists. You just specify the name of the fixture as the first argument to it, and then you can give it any number of values, and it will generate one test per value that you give it. And it will just take whatever fixture is there and overwrite it in your whole fixture stack. So in this case, we have the fixture random user, which has a parameter named username base. I don't have that fixture defined anywhere, so it will fail if I haven't overwritten that. But because I've put username base as Jose, when random user goes to request the fixture, which is username base, it's going to get a string, which is Jose, and so you can pass your parameter that way. And if you want a default value, then you just actually define the fixture that will be the default. Okay, so moving on from fixtures, this is a good time to talk about parameterization, which is one of the, I would say, the strongest strengths of parameters. Now, most of us will spell it with an extra E there, but the pytest team is very adamant that there is no E there. So the way this works is that you have a marker that's pytest.mark.parameterize, and you pass it just some collection or sequence of values, and you specify which parameter it has to go to, and it will create one test per value that you've specified. And there are these things that you can do that are a little bit fancier, like you can say, oh, this one is going to fail on anything earlier than Python 3.11. And when you run pytest, it will create all these tests for you. You can do something like this in unittest with an extension. There are a couple of different extensions that do this. The one that I found that looks like the best and has a very similar user interface as the pytest interface is this one called unittest parameterize. And with that, all you have to do is make sure that you're inheriting, instead of inheriting from unittest.test case, you inherit from unittest_parameterize.parameterize test case. And then this will mostly work. But one thing that will not work in pretty much any flavor of unittest is stacking parameterized decorators. In pytest, and I think unique to pytest, if you put two of these in a row, it will actually give you the Cartesian product of the parameters that you have. So if you want to test all the combinations of x being 4, 5, and 6, and y being 3, 2, and 1, you can do that by just stacking them. I wouldn't stack too many like that, because then your test suite is going to explode. But sometimes it's actually good to just explore the entire space of some functions' inputs. Okay, so the last thing I'm going to talk about in terms of pytest is plugins, because this is another great strength of pytest. pytest, it's very easy to write plugins for it, and it has a very broad ecosystem. And as a result, there's probably like a lot of different, if you think you need a plugin for something, there's a good chance that someone has already written that or a very similar plugin. And if there's not, it's pretty easy to write one for yourself. Some that I'd like to highlight would be pytest randomly. What that does is it takes your tests and it runs them in a random order, which sounds like something you might not want to do. But it's actually quite useful, because what it lets you do is it lets you have more confidence that you don't have accidental dependencies between tests. If test A is always run before test B, you're never going to see a failure where that would only occur when test B is run before test A. If all your tests are written to be independent, you should be able to run them in a random order. pytest xdist takes all your tests and just distributes them among different workers, so you can run them in parallel. That can speed things up, especially if you're just running it in one version of Python. Normally, I find that if I'm doing a test suite that involves 4 different versions of Python, xdist doesn't give me a huge amount of speed up, because I'm already parallelizing 4 different test suites. There's also pytest subtest. I didn't get to talk about subtests, but they're the one feature of unittest that I really miss in pytest, and lo and behold, there's a pytest plugin for it. A lot of people like pytest cov as well. It basically just puts coverage directly into your pytest, so it will handle invoking coverage for you. And then people have all kinds of other tooling that they've built into pytest plugins, right? There's profiling, which will just, some of these profilers, they'll just sort of generate a little report for you, or you can do benchmarking of your test suite. There's a couple different plugins for that. And then there's also these nice little fun plugins. We've already talked about pygments, which gives you the syntax highlighting. There's pytest hammer time, which takes all those little dots and turns them into hammers. And if in November, October time, if you want your pytest to be pumpkin spice flavored, you can use pytest pumpkin spice. And if you're the kind of person who had a lot of Winamp plugin skins, you might think I don't want standard out of the box pytest, right? You can use something like pytest sugar, and presumably you could fork pytest sugar and make this your very own changes to the look and feel. Okay, so getting to a recap, because I don't want to end on just a little joke. I'd like to just give an overview of what I think are the advantages of pytest, right? Especially for someone who's in a position of, we have a code base that is a whole bunch of unit tests, possibly millions of lines. How could we possibly adopt this? Well, for one thing, pytest is very a la carte, right? It can be adopted incrementally. You can use it just as a test runner. You can mix and match pytest style code, pytest and unit style code, even in the same file, right? You can have a unit test class, and then right after it, 5 different test functions that are just bare functions. And pytest will handle that just fine. Additionally, even though unittest is in the standard library, I would say that it shouldn't be a terribly controversial statement to say that today, pytest is the standard way to do testing in Python. It has a very broad ecosystem. It has, as a result of just the broad ecosystem, right? It has great documentation both on the pytest website and also just people talking about pytest. There's podcasts that are very focused on pytest. There's lots of blog posts. There's at least 1, maybe 2 books on pytest. Additionally, it's under very active development. I would say that pytest is much more actively developed than unittest. And in all my interactions with the pytest devs, they've always been very nice, very, very capable. And I would say that if your organization is finding that there's some absolute blocker in pytest, you may want to just reach out on the issue tracker and see if you can either add it as an option to pytest or make it possible for you to write your own plugins to satisfy your use case if plugins are not available. I suspect that the pytest devs will be more than happy to help you with that. Additionally, partially because of the active development and the ecosystem of people testing it and whatnot, pytest is extremely feature-rich, right? It has fixtures. I barely talked about the extent of what fixtures can do. Parameterization, again, I just gave a very brief overview. There's a ton more that goes into that. And then there's stuff I didn't even get to talk about, like how to write your own custom plugins. There's markers where you can add metadata to your tests. There's many more things like that. So, and of course, configuration. pytest is extremely configurable. And that can be a double-edged sword. But generally speaking, if you want to adopt something for your organization, it's a lot easier to sort of do it incrementally if you can configure it to at least start out the way you would like you're currently doing things. Okay, so that's the extent of my talk. If you would like to know more things that I've said about testing, I have some stuff on my blog. I alluded to subtests. There's a whole blog post about it and a podcast, like an episode of a podcast. I didn't do a whole series about this. And then in PyText's 2022, I gave a talk about exfail and skip. And exfail and skip, those are very, very useful decorators. And it's actually a pattern that you can't replicate in unittest. It's just not well supported. So I would highly recommend looking at that as more evidence for why PyTest is such a powerful framework and why you might want to adopt it. Okay, well, thank you very much for coming to my talk. And I guess I have a couple minutes to take questions if anyone's interested. Oh, right. And the first question is probably going to be about the shirt. So yes, I do know it's awesome. Presumably there's a microphone, right? Yeah, I can repeat your question if you. So the question is that sometimes people will organize their PyTest tests into classes just out of habit, even if there's no shared state. And what are my thoughts on that? I would say you can do it if you want, but it's not exactly idiomatic, right? So I would reserve classes for when you have a specific use case for the classes, right? I also am not a huge fan of inheritance, so I would say to the extent that classes encourage the use of inheritance-based patterns, I would be against that.
Hello. They gave me a microphone.
Oh, excellent.
So I'm sure there's a lot of people here who work with Django. Hands up, who works with Django? Cool. So You might notice that in the official Django documentation to this day, they recommend that you use unit tests, and they say that the Django test case subclass is unit test, and all the documentation points to unit test. And something I've struggled with a little bit in the past is writing unit tests in Django that use pytest. We do use pytest with the Django pytest plugin, and it works well. But there are a few scenarios where it hasn't, such as fixtures that create objects in the test database. You have to run Django db blocker.unblock to unblock the database and create objects, and sometimes you can get yourself into a situation where you create an object and it doesn't delete it, it doesn't clean it up, then you go to run the test again and you get database errors and you have to jump in and delete the test database. So anyway, my question is, have the people that work on pytest talked to the people who work at Django at all and maybe talked about updating what they use, or I don't know?
Well, so I am not part of either of those groups of people, so I am not really privy to whether or not they have talked to each other. I have talked to both groups of people in various forms, and I think pretty much everything that I've said about the pytest devs also goes for the Django devs. They seem very capable and very nice, and they've always been very interested in sort of finding clean patterns of code and how to develop that. So if there's not an active conversation about making pytest with Django easier or better, I would recommend starting a thread in whatever the appropriate forum would be, whether that's in one of the Django mailing lists or on an issue tracker, because I suspect that you'll get takers. The Django people seem like very nice, and you know, I think they've always understood any concerns that I've ever brought to them.
Thank you everyone for attending.
All right, well, I'll hang around in the hallway afterwards, so anyone who wants to talk can certainly do so.
Okay, thank you.